So this is the fifth lecture which discussing about AC transform. Okay. Now we'll see one problem. Here we can see that it's a finite sequence x of n is defined as x of n is a signal and it's a finite sequence signal. Okay, and here it is indicated as an zero index. Okay, and you need to find out the AC transform and its ROC. Now we can see what's the signal is. Okay. So here is a signal and you can see that at n is equal to 0, here this is 1 and this is 2 and this is 3, and here you can mark -1, -2, -3, etc., -4. This is in time domain, and you can see that the signal value at n is equal to 0 is -2. So here we need to mark -2. Okay, here it is -2 and here it is x of 1. This is 1, 2, 3. So at 1 it's 0, and you can see at 2 it's 4. Signal magnitude is 4, and here again it's -3. Okay, it's a negative value, and you can see in negative side is 3 and 5, means here it is -1 and this is -2. So -1 the function magnitude is 2, sorry, it's 3, and at -2 it's 5. So this is a signal x of n, and now we need to find out the AC transform of the signal. And AC transform of a signal can be written as x of z is from -infinity to infinity, x of n is raised to -n. But it's a finite sequence signal or finite sequence, so this signal is having non-zero magnitude only from -2 to 3. So we don't want to evaluate from -infinity to infinity. So we can start from n is equal to -2 onwards. So we can write this formula again. X of z is equal to sigma n is equal to -2 to 3. X of n is z raised to -n. So now we can expand this. So we can write x of -2 into z square plus x of -1 into z raised to 1 plus x of 0 into z raised to 0 plus x of 1 into z raised to -1 plus x of 2 into z raised to -2 plus x of 3 into z raised to -3. Now we can substitute these values. So you can see that x of -2 is 5, okay, and z square, and x of -1 is 3. So you can expand like this: 5 into z square plus 3z, and x of 0 is -2 and z raised to 0 is 1. So you can write -2, and there is no term for x of 1 is 0. So 0 into z raised to -1, so the whole term will become 0. And next term is x of 2. X of 2 is 4. So you can write plus 4 z raised to -2 minus 3 z raised to -2. So this is the AC transform of the signal given in the question. And now we can think about the ROC. Okay, in this case you can see that if you substitute this AC transform exists in all z except at, you can see that if z is equal to 0, sorry, if z is equal to 0, what happens? If z is 0, you can see that there is a negative term, z raised to -2. So this is actually 1 by z square. Means if z is equal to 0, if you substitute here, it becomes infinity. Okay, and similarly, if directly if z is equal to infinity, the positive terms z square and z becomes infinity. So you can say that the ROC, so R of this particular question is the entire z, or I can by say that the entire z value except at z is equal to 0 and infinity. So I can conclude like this: the result converges, or the z transform exists for all z, okay, as all values of z, all values of z except at z is equal to 0 and z is equal to infinity. Or you can say in other words, the z transform is between 0 and infinity. Okay, you can see that is not equal. Okay, it's greater than 0 and less than infinity. Means if it is z is equal to infinity or z is equal to 0, the result becomes infinity. So in all other values, we can calculate this transform. So z transform is the entire z plane except at z is equal to 0 and z is equal to infinity. So only in these two cases z transform does not exist, and all other cases z transform exists. So now we'll discuss another question is again as a finite sequence. But here in the question it is given x of n is equal to a raised to n, and for the limit 0 to n minus 1, and a is not equal to 1 and 0 otherwise. Find the x of z and its ROC. Again it's a standard question, and again we need to substitute this transform formula here. We need to evaluate this formula. And one more thing, in this question as a finite sequence signal, this signal exists from only from 0 to n minus 1. Means I can rewrite this formula like this: sigma as n is equal to 0 to n minus 1, not up to infinity. Okay, it's 0 to n minus 1, a raised to n into z raised to minus n. And if you rearrange this, you can write sigma n is equal to 0 to n minus 1, a z raised to minus 1 the whole raised to n. Okay, now we need a formula to evaluate this. So this is the standard formula for a finite sequence. Okay, and you can see that if the summation is from 0 to n, a raised to n, you can write 1 minus a raised to n plus 1. It's very important. If it is from 0 to n, total there is n plus 1 values. That's why it's a raised to n plus 1 when a is not equal to 1. And if a is equal to 1, it's simply n plus 1. Okay. Now here it is 0 and n minus 1, but the formula is 0 to n. So if it is n, you need to write n plus 1. Now it is n minus 1. So I can write like this. Okay, it's 1 minus, and one more thing, in place of a, here it is a is raised to minus 1. Okay, so this is the common term. A this is not capital N, this is small n. Okay, and here it is a is raised to minus 1. Okay, and all raised to n, because if it is 0 to n, you need to write n plus 1. So here in place of n, it is given n minus 1. So if you substitute n minus 1 here, it becomes n minus 1 and plus 1. Okay, this is the limit, so it becomes n. So and the denominator you can write 1 minus a raised to z raised to minus 1. Now if you rearrange this, you can write like this: 1 minus a raised to n divided by z raised to n divided by 1 minus a by z. Okay, again if you take the LCM and if you simplify this, you will get z raised to n minus a raised to n divided by z raised to n, okay, the whole divided by z minus a divided by z. Okay, and after simplification you can write z raised to n minus z raised to a divided by z minus a, and in the numerator it's z and the denominator it's z raised to n. Okay, and if you simplify this, z is raised to 1 actually. So I can put this, I can bring this z to denominator, so I can simply write it 1 by z raised to n minus 1. So this is the final answer. Okay, and if you think about the ROC of the question, and in the ROC, okay, if you look at the denominator, okay, there is one term is z minus a and other term is z raised to n minus 1. Means if you equate the denominator 0, okay, if you equate the denominator equal to 0, you will get 1 z raised to n minus 1 is equal to 0, and other term is z minus a equal to 0. So you will get two pole positions, one is here a and other one is at 0. Okay, so these are the two poles. So you can construct about two circles, one is z is equal to 0 and z is equal to a. But there is one interesting point is here, there is a factor called so there is some mistake. This is a raised to n. Okay, if you look at this particular term, z raised to n minus a raised to n. So if you equate to 0, if you equate numerator equal to 0, you will get one factor like this, or if you factorize this term, you will get 1 0 like this. Okay, in numerator you will get a one term z minus a, and these two terms, one is at the numerator and one is at the denominator. These two terms cancel. Okay, so there is no pole like z minus a. So there is no pole at z is equal to a, no pole, because this pole cancel by the 0 which is at the numerator. Okay, so we'll get only n minus 1. Okay, this pole. Okay, this is the pole we are indicating. So the z transform ROC is entire z plane except at z is equal to 0. Okay, except at z is equal to 0. So ROC is entire z plane except z is equal to 0. So we can write ROC like this: modulus of z greater than 0. Okay, so entire z plane except at z is equal to 0. So this is the ROC. And now we'll discuss another question. Again, it's a finite sequence and is also indicated as a right-handed sequence. Okay, or we can say it's a causal sequence, means the signal exists only on the positive side. Now we can see that the signal exists only from 0, 1, 2, 3. Okay, so you can see here it is minus 2, and here it is 2, and here it is 4, and at 3 it's minus 3. Okay, this is the signal x of n. Now we can write the z transform. The general formula for a z transform is like this, and we can rearrange this equation, and we need to calculate only from sigma n is equal to 0 to 3, x of n is z raised to minus n. And if you substitute the n values, I can write like this: at n is equal to 0, x of 0 into z raised to 0. So you can write minus 2. Okay, plus 2 is z raised to minus 1, plus 4 is z raised to minus 2, minus 3 is z raised to minus 3. So this is the z transform. And now we need to think about the ROC. Okay, if you look at this particular equation, the all terms are negative. Okay, the powers are negative, means z becomes 1 by z, 1 by z square, 1 by z cube. Means this equation goes to infinity when only when z is equal to 0. So we can say all Z except at Z is equal to 0. So when you discuss about the causal signal, I can say that ROC is all values of Z except at Z is equal to 0. So this is a standard question. You need to think when it is a causal or a right-handed sequence, the ROC is very important. Region of convergence is all values of Z except at Z is equal to 0. Okay. So if you think about the ROC, this is the ROC. Entire values of Z only at Z is equal to 0 as a transform does not exist. Okay, except at Z is equal to 0. We'll think one more question. Here again it is written as anti-causal. Okay, similar to the previous one, but only difference is anti-causal, or it is known as left-handed sequence. Means the signal exists only in the negative side. Okay, so here it is 0, here it is -1, -2 and -3. Okay, 0 the function magnitude is -3, and -1 the function magnitude is 4, and next value is 2, and next value is -2. So if you think about this transform, this is the general formula, but the signal exists only from n is equal to -3 to 0. Okay, x of n into z raised to -n. So I can write like this: -3 z cube plus 2z square plus 4z minus 3. So this is a transform of the signal. In this case, this equation becomes infinity only when the z is equal to infinity. Okay, so I can say the ROC is entire z plane except at z is equal to infinity. So I can conclude this concept. If the signal is anti-causal, okay, if the signal is anti-causal, then this is ROC is all values of z except at z is equal to infinity. Okay, is about anti-causal signal. Now we'll discuss solution of the previous lecture in lecture 4, and one question is x of n is -2 raised to n into u of -n, and the answer will be z by z minus 2, and the ROC will be modulus of z less than 2. If you check the second question, is almost similar to the first one, but only difference is there is no minus sign. Okay, and the answer will be z by 2 minus z, and the ROC will be same. And for the last question, actually there is two part. One is 5 by 6 whole raised to n into u of n, and the transform for the corresponding signal is z by z minus 5 by 6, and the ROC is given by modulus of z as greater than 5 by 6, this much. Okay, and the second part is minus 6 by 5 whole raised to n into u of minus n, and the transfer for the question is z by z minus 6 by 5, and the ROC will be modulus of z less than 6 by 5. Means the combined ROC will be like this. There will be 2 points. One is 5 by 6 and another one is 6 by 5. So we'll get 2 poles, and now we need to construct 2 circles with radius 5 by 6 and 6 by 5. Okay, so we'll get 2 circles, and one signal is converges if modulus is greater than 5 by 6, means greater than this, so it will be like this outside the circle. Okay, and another one modulus of is less than 6 by 5, so it will be inside the circle. So the common area will be like this, as a strip between two values 5 by 6 to 6 by 5. So that's a ROC of the combination of these two signals.